Hey there, my name's Charles, and in this Networking 101 video, we're going to demonstrate how to create and configure a network security group, create an inbound rule on that NSG, and then associate the NSG with a subnet. Make sure to like the video and subscribe to the channel to learn more about Azure. So when we think about security within a virtual network, there's kind of two things that we can use and think about in that perspective. First thing we need to think about and be aware of is that the virtual network itself is the security boundary. So subnets within a virtual network by default can communicate with each other. So if we go into our demo 01 virtual network here, our address space is 10.2.0.0/16, pretty big network. If we look at our subnets, we have two subnets created, both /24s at 0.0 and 1.0. So again, thinking that the virtual network itself is the security boundary, default configuration, subnet 0 and subnet 1 can absolutely communicate with each other. Any port, any protocol, doesn't matter, full open communication. Now, of course, in a production environment, as we're deploying services, virtual machines, access to private endpoints for PaaS services, probably not the type of configuration that we want. So there's two ways to go down this route. One is to deploy a firewall that provides layer 7 packet inspection, packet filtering, as well as network rules for source and destination traffic. Probably a recommended route, especially if there's internet traffic or certain PaaS services in play there, specifically databases, where we want some packet inspection. But if it's maybe a dev environment, if it's not an environment where we need the additional cost of a firewall to do that packet inspection, we just need to restrict traffic, then we can use what we know as on-prem as an access control list. In Azure, these are called network security groups. And so whereas an Azure firewall performs layer 7 packet inspection, a network security group really just does packet filtering. So it's only going to look at the header of the packet. It's not actually doing packet inspection. So it's going to look at the things like the source IP address, the destination IP address, the port number, the protocol that's being used. What is the header information of that packet? Does it meet one of the rules that exist in the network security group, either from an outbound perspective? Maybe if, say, we are going from a VM on subnet 0 to a VM in subnet 1, we could have outbound rules here on the first network and then inbound rules here on the second network. And those might be different, depending on if we have more subnets here or other virtual networks that are peered, what the different rules are for leaving a virtual network versus entering a virtual network. So network security groups are different objects, thinking in terms of Azure. This is another resource type that we have to go and create, and that we'll come back and associate with a subnet later. So we can use the search bar here at the top, start typing in network security groups, select that from the list of services here, and we'll go ahead and create a network security group. Just like every other Azure resource, it has to live in a resource group within your subscription. We'll put that in our Twitch demo resource group. And we'll keep with our naming conventions. We'll call this NSG in East US. And this is going to go on the demo subnet 0. So we'll review and create this network security group. Create the object, shouldn't take but a minute or so. And there we go, deployment complete. So we'll go to the resource. So now we're on the network security group, and it has some default inbound and outbound rules. So it's not currently associated with anything. We've only created the object. We would have to associate this network security group with a subnet for these rules to apply. But pretty much, inbound is going to allow things from the virtual network or that are tagged from a virtual network. So again, that subnet to subnet communication would be allowed. An Azure load balancer would be allowed. Peering connections, so from another virtual network, would also be allowed. And then we would implicitly deny anything else. So if it was internet traffic to the VM, that would be denied. Outbound kind of works the same way, but a little bit different. So virtual network to virtual network, also explicitly allowed. And then we kind of have like an interesting priority of rules here that are default. So the first here is allow internet outbound, which is a default rule, meaning, and the source is anything on whatever we're associated with on the subnet. And then the destination is to the internet. So just public internet, anything out there. And that is allowed by default. And then just like access lists kind of work with Cisco and Juniper devices, if we go look at an access list, there is an implicit deny at the end of an access list. It works the same way here with a network security group. We have a deny all outbound, any rule, doesn't matter where it's coming from, where it's going, deny the traffic. But notice the rule priority here is after the internet rule. So, if the destination is to the internet, this allow rule would still take precedence because of the priority here. It has a lower number, and thus it's higher in the priority list. The way that network security group rule processing works is that as soon as a rule matches, that's the rule that gets applied. So pretty much, any traffic here would match an outbound rule, and by default it would be allowed because it's either going to be going to a virtual network or to the internet, and both of these cases are allowed. This deny rule really doesn't come into play unless we start to modify the routing or the other rules that we'll create on our network security group. Now, these are default rules. We cannot delete them, modify them, but what we can do is create rules that have a higher priority. And so if we go over here to the inbound rule list, you'll see here that we have no selection options. We can't really do any things with those. And so if you wanted to in the portal, you could just hide them. They're there in the background. They're going to work the way that they're going to work. We can't really change them. We could just override them by creating additional rules. And so if we're going to attach this network security group to subnet 0, and maybe subnet 0 is going to be a web server. It's going to be running IIS or Apache, Nginx, accepting some type of web traffic. Well, that means we probably want to accept 443. So we'll add a rule here. So it doesn't matter what the source is. We're going to say this is a web server on the internet. Source port ranges as well. We can't control what the source port number is. Say our web server is a specific IP address. So if we know that 10.2.1.4, which is the first usable address, actually subnet 0, so we're going to change that to 0.4. So 10.2.0.4 is our web server. This is a virtual machine that we're going to deploy. It's going to have IIS or Apache running on it, and we're going to accept web traffic. Well, we can say that the specific service that we're using is HTTPS, and so it kind of hard codes the port range, makes it uneditable. If we could select a custom service here if we wanted to change the port number. But by selecting the service, it sets that to 4434. It also sets the protocol to TCP. And then we can, say allow or deny. This is one that we want to allow. It's a web server. We need this traffic. And then here's probably one of the most important parts of the network security group, the priority. So as we add more rules to our network security group, that rule processing is going to be done in order from the lowest numerical value. So in this case, the lowest priority that we can set is priority 100. That would put it at the top of the list and mean that it's processed first. Now for flexibility, let's see if, yeah, it doesn't show us in the note. So I'm going to put a value that's not valid here. And so the error tells us, hey, the priority has to be between 100 and 4096. And so notice the default rules are much higher than that, right? Like it's 65,000 plus. And so this is where we can kind of override the default rules by obviously setting a priority that is going to be a lower number. But then if we have some complex routing, some complex scenarios where we want to allow specific traffic, deny specific traffic, and kind of have more of a funnel into this virtual network, this is where the priority becomes super important. And so I don't typically ever recommend anyone use priority 100 because now if we wanted to come back and, modify this funnel a bit, well, this is the highest priority we can set. So we can't really override this now without changing all of the other rules or coming in and reconfiguring the values. So this is not like a good long-term priority to put, in case you need to change things later. Since the values go from 100 to 4,000, I typically recommend kind of start in the middle. Start at 2,000. It's still going to be, a higher priority than all of the inbound rules. And then this gives us a ton of flexibility to add either more rules after this one. We still got 2,000 in one direction. Or if we need to change the priority later, add something before this, we've got 1,900 the other direction. So if you start in the middle here, it gives us a good amount of leeway to add additional rules later that go one way or the other. The name is just for visualization. It's what it's going to show up here as the name. Typically the default is good unless you've got a very specific, source to destination, and then you're trying to say that, okay, from the app gateway to the virtual machine, or vice versa. But we can click add here. That'll add our HTTPS rule to the list. It's still adding based on the notification here. All right, rule created. Refresh, and there's our rule. And notice this one is configurable. It's got a link here. We could click that. It'll open the menu back up. We could change any of those things again. And so now this is an inbound rule for HTTPS to this specific IP address, where assumingly that would be our virtual machine that's running a web service. Now, remember, we've created the network security group object. Now we've created a rule, but going back to the overview page, this still is not associated with our virtual network in any way. So network security groups can be associated with two different things, either a subnet, not the entire virtual network, but a subnet, or a network interface. Again, in general, recommended to really just use subnets. Network interfaces have its use cases. It's much more granular in terms of management, and so the administrative complexity can get nightmarish if you have a bunch of network security groups on network interfaces. Avoid it if you can. There are certain use cases where it's unavoidable, but try to only associate network security groups with subnets. And so to do that, we would go over here to subnets. We could do this from one or two places, and I'll show you both. So from the network security group, we can go to subnets here, click associate, and then it'll ask us, okay, what virtual network? And so we're working with our demo virtual network and subnet 0, because we called this subnet 0. This is the subnet that we'll associate it with. So to do that, we could click OK. It'll take just a second and associate. And that's done. Now we could go back to our virtual network. And I'm going to go to the Twitch Demos resource group. So if I go back into our demo virtual network, go to subnets, now we'll see here this column was blank before, and now it's showing that our network security group is associated with subnet 0. Now the other place that we can make this configuration change is from the subnet. So if we select the subnet to configure it, there was that drop-down menu that said none before. Now it says our demo subnet 0 network security group. So this is the other place where we could make this change or association. So it doesn't matter whether you select it here in the drop-down menu. If you select the subnet association in the screen we just configured, they both do the same thing. At the end of the day, as long as this column says the appropriate network security group, then it's associated correctly. And so now we've allowed inbound HTTPS traffic or secure web traffic from the internet to that .4 address, assuming that that will be a virtual machine on the subnet. And so that's how we create and configure network security groups for our virtual network and our subnets. Thanks for watching. I hope you were able to take something away from this video. I create these on Twitch every week, every Friday afternoon. If you have any questions that you would like to come ask live and in person, feel free to come follow me on Twitch as well. Thanks for watching.